What is strain? Strain is the comparison between how much an object is stretched and how long it was originally. Let's take a closer look at what that means. Take this steel welding wire, for example. It's about 5 inches long. When I pull on it with my hands, it doesn't seem to stretch at all. But it actually is stretching a little bit. I'll show you. You see, if I take a longer piece of the same wire and pull on it with the same amount of force, about 20 pounds, you can easily see it stretch. Even though one wire stretched more than the other, both wires experienced the same amount of stress and the same amount of strain. Strain is the change in the length of an object divided by its original length. The longer wire is 500 inches long. By pulling on it with 20 pounds of force, I can stretch it about 1/2 inch. Since we know the change in length and the original length, we can calculate the strain. Strain is the change of length over the original length. The strain was about 0.5 inches divided by 500 inches. 0.5 divided by 500 is equal to 0.001. So the strain was 0.001. But what about the units? You might expect the units to be inches, but when we divide inches by inches, the inches cancel each other out and the value becomes unitless. And we sometimes write inches per inch or millimeters per millimeter behind strain values to remind us what happened to the units. But strain is strain no matter what units of length we use. Let's do the same experiment with metric units. The long wire is about 13 meters long. When we apply a force of 90 newtons, the wire stretches 0.013 meters. 0.013 divided by 13 is equal to 0.001, the same answer we got when we used inches. The strain is the same because it's unitless. Just be sure to use the same units for the change of length and the original length. Now, just for fun and for a way to review our stress video, how much stress was I able to develop in the wire? Remember that stress is force per unit area. The force was 20 pounds, and the area of the 0.03 inch diameter welding wire was 0.0007 square inches. 20 over 0.0007 is almost 29,000 psi. Understanding the relationship between stress and strain is actually pretty important in the world of engineering and design. We'll take a closer look at that in the next video.